Hey there YouTube, Brad here, aka Unique FLH. Let's talk about HomeKit. Now we could talk about my Harleys, Touring Models FLH stuff. We could talk about my 2010 Audi A3, which has been slightly modified. Or we could talk about when an old dude does BMX stuff. But today, let's talk about HomeKit again. Specifically, let's talk about some of the things that you can do with a Raspberry Pi that's integrated into your smart home ecosystem. So there's a lot of us that are using a Raspberry Pi to run stuff like HomeBridge or Hoobs or Home Assistant in order to bring non-HomeKit compatible devices into the HomeKit ecosystem. If you're running HomeBridge on a Raspberry Pi device, you may have noticed that on the Raspberry Pi there's a bank of little pins on the circuit board. Those little pins allow a ton of additional functionality within the Raspberry Pi for connecting devices to. These pins, called GPIO, can be used for sensor inputs. They can also be used as outputs, and they can control other devices via your Raspberry Pi circuit board. These general purpose input output or GPIO pins, if paired with the proper HomeBridge plugin, such as the HomeBridge GPIO device plugin, can be configured and set up to do some really interesting things, such as bring dumb devices into your HomeBridge and HomeKit ecosystem. In order to get my dumb car locks into HomeKit, I went and I grabbed a power relay expansion board for my Raspberry Pi, which allows me to emulate a button push on a car remote key fob. Well, now a circuit board isn't going to physically push a button on a key fob remote for you, but with the use of some wires and some soldering skills and a little creativity, you can emulate a button push on a key fob remote. To sort of explain, I started with an extra key fob remote that I had, and I took it apart so I could see the internal circuit board. So for the key fob on my Chevy, I used a test lead and started interconnecting solder points that were around the center button on the circuit board. Essentially, I was looking for something that when I touched two different points together, it would emulate a button push and get the vehicle to lock. Now, there are way more technical and sophisticated ways that I could have figured out which two points, when connected, emulated a button push, but literally standing next to the car and using a little test wire got me to these 2 points in about a minute and a half. Super easy, and I knew where I needed to solder wires. Once I knew which points on the board I needed to use, I went ahead and drilled the hole in the key fob and I soldered some wires to the circuit board. Once I had that done, I also did the same thing to an Audi key fob that I have. Each key fob uses color-coded wires from Cat 6, and then they run back to a little junction connector that again uses Cat 6 to go to an Ethernet port, and I mounted the whole thing in a little Ethernet biscuit jack box. The little Ethernet box that holds the key fobs is mounted in my basement up on the ceiling rafters, and then it plugs into other Cat 5 that I have running back, and again through color coding I have it attached to the relays on the GPIO board. Once I got all the wiring done, then all I had to do is go into HomeBridge and do the configuration shenanigans. And it now, when I tap one of the buttons, it will lock the car by momentarily closing that circuit and emulating a button push. Now, this obviously wasn't a detailed, in-depth how-to, but more of a way to showcase some of the things that can be done and the additional functionality that you can get out of a Raspberry Pi using those GPIO pins. In addition to my car locks, I also have integrated into HomeKit my dumb smoke detector system, my dumb doorbell. I've created my own temp sensors, and I've also created my own water leak sensors. There's definitely a lot of cool stuff that can be done. If you'd like to see more videos or hear more details about any of those things, drop a comment down there, like the video, whatever it is you think you need to do, and thank you for watching.